So when you go to factor a quadratic expression, you need to decide what type of factoring it is. One type that we've studied is GCF, which we said you should always try first. However, in this example, 4, 4, and 15 don't have any common factors, and while the first two terms have an x in it, the last one does not. It's also not a difference of two squares because there are 4's here, but 15 is not a perfect square, and the difference of two squares needs to have two terms, but this one has 3. So this one is a trinomial. And in this case, the leading coefficient is not 1. So we can't just look for two numbers that add to be 4 and multiply to be negative 15. In this case, we have to do one of the other methods, which I tend to do the guess and check method. What I'm going to do first is factor the first term. It either factors into 4x and x, or 2x and 2x. And factor the last term into 1 and 15, or 3 and 5. And this is a guess and check method. We do know that there are two sets of parentheses, so I can set those up. And I am guessing when I'm going to put the 4x and x first, and the 1 and 15 second. But if I check by multiplying these back together, 4 times 15 is going to give me 60x. On the inside, I get 1x, and I cannot make those add to be the 4x that's in the middle. I can try reversing the 1 and the 15. So on the outside I have a 4x, and the inside I have a 15x, but again, that will not add in any way to be 4x. So instead of trying 15 and 1, I'm going to try 3 and 5. And I'm guessing when I put the 3 first. If I multiply the outside together, I get 20x. On the inside, I get 3x. Again, those do not add to be 4, so I try reversing those numbers one more time. The 5 here and the 3 here. On the outside, I get 12x. The inside, I get 5x. And again, they don't add to be 4x. So what that tells me is that 4x and x was not the choice that I needed. So I'm going to switch and use the 2x and the 2x. I'll keep the 5 and the 3 even though I'm going out of order just because I have them there already. If I multiply the outside two numbers together, I get 6x. The inside two give me 10x, and if I had a positive 10x and a negative 6x, that would add to be 4x, which is what I'm looking for. So on the outside, the 2x times 3 has to be negative, so it's going to have to be a 2x times negative 3. And on the inside, I need a positive, so I have to have a 2x times a positive 5. I double check my work just to make sure. I multiply the 5 and the negative 3 and make sure that it does actually give me negative 15, which in this case it does. Since this one just says factor, that is the answer for the problem. If it was set equal to 0 and the directions say solve, you would have to take it a step further and set each factor equal to 0 in order to solve.